Hi, welcome to the video on triangle congruence with two methods called AAS and ASA. AAS stands for angle, angle, side, and ASA stands for angle, side, angle. These two methods help us prove that triangles are in fact the same. If you know that two angles in one triangle are congruent to two angles in another triangle, and the side that connects those two angles is congruent to the side that connects the two angles in the other triangle, then in fact those two triangles are the same. This method actually comes from this method. It's again if you have two angles in one triangle congruent to two angles in another triangle, and the side not in between them in both triangles, and that side has to be connected to the same angle. Then it turns out that triangles are congruent in that case. You got the definition. I explained it a little bit in class. I'm going to link you to the actual official definition in the description box as well. And we're going to go through it here. Let's look at our first example here. Hopefully you remember that when you see pictures like this, when you see two triangles joined at one point, immediately you have something to label for me. You've got vertical angles right here. And you're going to see that again in a couple other problems we do. Knowing that, we can look at what we have. I've got one set of congruent angles. Angle B is congruent to angle A. I've got another set of congruent angles that I just labeled. ECD is the same as ACB. That's two angles. So far it looks like it might be one of these. Now we just have to look at the side. I've got CB congruent to CE. So I've got two sets of congruent angles, one set of congruent sides. So we look, is the side in between those angles or is it not in between? Does this side connect these two angles? Yeah, it does. CB connects angle C and angle B. In the other case, this side EC connects angle E and angle C. My two angles that were part of the congruent pairs. So since I've got angle, then a side in the middle, then another angle, this is method ASA. Angle, side, angle. Now to do the triangle congruence part, you got to be careful. Triangle ACB, A to C to B. With this method, it's really easy because you've got no mark on this angle, an arc with two tick marks on it in that angle, and you've got just a regular arc mark in angle B. So you just match them up here. No arc at D. Next was C. Well, C had an arc with two tick marks on it. C has an arc with two tick marks on it here. D, C, and the last one's got to be B. Notice B matches with, oh wait, I didn't mean B, I'm sorry. B matches with E. Oops. Alright, there you go. ACB is congruent to DCE by ASA. Alright, there's the triangle congruence, there's the reason. Let's look at the next one. This is similar. We look what we have. I have this angle here is congruent to this angle here. RQS is congruent to SQT. That's one set of congruent angles. I've got one angle so far. Here I was given that this is 90. Hopefully you remember that this is a straight line. And because this is a straight line and this is 90 degrees, then so is that. Now I've got another pair of congruent angles. These are both the same. Congruent means the same, and they're both 90. So I've got two angles so far. One of these looks like it might be good to go. The problem is they both have S's in them, and right now I don't have any congruent sides. But hopefully you remembered from class that when two triangles are shoved together and they share a side like this side SQ, it turns out that side is the same in both triangles. There's no way, like if you had two rooms next to each other and they shared a wall, well, that wall's the same length on both sides. So same deal. These triangles share this side. If it's 10 inches on the left triangle, SQ, then in the right triangle, SQ is also 10 inches. There's no way it could be any different. So when that happens, you can label that side SQ congruent to itself because it's in both triangles. And now we look, let's see. Now I've got a side. To determine which one it is, I've got to make sure, is the side in between those angles or is it not? Let's see. In the left triangle, here's my two angles. They are connected by this side. Angle S and angle Q are connected by side SQ. So far it looks like ASA. Let's make sure it's the same case in the other triangle. Angle, angle, and there's the side connecting them. So it is ASA. Alright. The only time that wouldn't really work is if you had two separate triangles. Maybe if you had something like this, two little guys, and maybe you had this angle here and this angle here, and this angle here and this angle here. So there's my two sets of congruent angles. In one of them you've got the side in between, and the other one is over there. That wouldn't work. So if the marks were done like that, then that's no good. Because here it's angle, side, angle, but there it's not. There's no way I could pick that triangle up and put it on top of that one so that all of my marks match. Whereas here I could just flip this guy over very nicely. This one I would have to spin it, but then it would come around. Finish this up, RSQ, R to S to Q. Hopefully you see RSQ. Let's see, R doesn't have any markings in it, neither does T. Then RS, well, S is 90, so is S in this one. And then the last one has got to be, if it was RSQ, TSQ. So far so good. Example 3. You've got triangle JKL, and you've got this triangle above it. Well, I again see one arc and one arc. That's one set of angles, congruent. J and F, another set of congruent angles. That's two angles. Again, this is looking good, but I gotta see, do I have any congruent sides? Well, I do. JL is the same as EF. And you want to make sure, is this side connected to these two angles? Yeah. Side EF connects angle E and angle F. Side JL connects angle J and angle L. So this is angle side angle. And let's see, J to K to L. J, K, L. The arc that has two tick marks, nothing, one arc, one regular arc. So 2, nothing, 1. F, D, E. That's that. Again, the only way this wouldn't work is if maybe this angle was there. Then I'd have two angles on a side, but then this has two angles on the side, not in between them. Okay, this side here doesn't connect J and K, so that wouldn't work. This is following the angle side angle idea, but this is following something different. Okay, so that wouldn't work. Move that back. Nope, it was the angle I moved. Right, where was it? Again, it was. Sorry, my brain's not working right. It's been a long day. Anyway, moving on to example 4. This one, let's see. They're not put together like one of these two, so I can't label a vertical angle, I can't label a congruent side. And I noticed that if I really look at this, I've got one set of angles and a second set of angles, and that's it. I don't have any sides. And angle is not a congruence method. It is a similarity method, but it's not a congruence method. So this is no good. This is just not congruent. You leave it alone.